Aluminum wiring. According to the InterNACHI Home Inspection Standards of Practice, a home inspector is required to report upon single-strand, solid conductor aluminum branch circuit wiring if observed by the home inspector. Between approximately 1965 and 1973, single-strand aluminum wiring was sometimes substituted for copper branch circuit wiring in residential electrical systems due to the sudden escalating price of copper. After a decade of use by homeowners and electricians, inherent weaknesses were discovered in the metal that led to its disuse as a branch wiring material. Although properly maintained aluminum wiring is acceptable, aluminum will generally become defective faster than copper due to certain qualities inherent in the material. Neglected connections in outlets, switches, and light fixtures containing aluminum wiring become increasingly dangerous over time. Poor connections cause wiring to overheat, creating a potential fire hazard. In addition, the presence of single-strand aluminum wiring may void a home's insurance policies. Inspectors may instruct their clients to talk with their insurance agents about whether the presence of aluminum wiring in their home is a problem that requires changes to their policy's language. Facts and figures. On April 28, 1974, 2 people were killed in a house fire in Hampton Bays, New York. Fire officials determined that the fire was caused by a faulty aluminum wire connection at an outlet. According to the Consumer Product Safety Commission, the CPSC, homes wired with aluminum wire manufactured before 1972, or old technology aluminum wire, are 55 times more likely to have one or more connections reach fire hazard condition than a home wired with copper. Aluminum as a metal. Aluminum possesses certain qualities that, compared with copper, make it an undesirable material as an electrical conductor. These qualities all lead to loose connections where fire hazards become likely. These qualities are as follows. Higher electrical resistance. Aluminum has a high resistance to electrical current flow, which means that, given the same amperage, aluminum conductors must be of a larger diameter than would be required by copper conductors. Less ductile. Aluminum will fatigue and break down more readily when subjected to bending and other forms of abuse than copper, which is more ductile. Fatigue will cause the wire to break down internally and will increasingly resist electrical current, leading to a buildup of excessive heat. Galvanic corrosion. In the presence of moisture, aluminum will undergo galvanic corrosion when it comes into contact with certain dissimilar metals. Oxidation. Exposure to oxygen in the air causes deterioration to the outer surface of the wire. This process is called oxidation. Aluminum wire is more easily oxidized than copper wire, and the compound formed by this process, aluminum oxide, is less conductive than copper oxide. As time passes, oxidation can deteriorate connections and present a fire hazard. Greater malleability. Aluminum is soft and malleable, meaning it is highly sensitive to compression. After a screw has been over-tightened on aluminum wiring, for instance, the wire will continue to deform or flow even after the tightening has ceased. This deformation will create a loose connection and increase electrical resistance in that location. Greater thermal expansion and contraction. Even more than copper, aluminum expands and contracts with changes in the temperature. Over time, this process will cause connections between the wire and the device to degrade. For this reason, aluminum wires should never be inserted into the stab, bayonet, or push-in type terminations found on the back of many light switches and outlets. Excessive vibration. Electrical current vibrates as it passes through wiring. This vibration is more extreme in aluminum than it is in copper, and as time passes, it can cause connections to loosen. Identifying aluminum wiring. Aluminum wires are the color of aluminum and are easily discernible from copper and other metals. Since the early 1970s, wiring device binding terminals for use with aluminum wire have been marked CO/ALR, which stands for Copper/Aluminum Revised. Look for the word aluminum or the initials AL on the plastic wire jacket. Where wiring is visible, such as in the attic or electrical panel, inspectors can look for printed or embossed letters on the plastic wire jacket. Aluminum wire may have the word aluminum or a specific brand name, such as Kaiser aluminum, marked on the wire jacket. Where labels are hard to read, a light can be shined along the length of the wire. When was the house built? Homes built or expanded between 1965 and 1973 are more likely to have aluminum wiring than houses built before or after those years. Options for correction. Aluminum wiring should be evaluated by a qualified electrician who is experienced in evaluating and correcting aluminum wiring problems. Not all licensed electricians are properly trained to deal with defective aluminum wiring. The CPSC recommends the following 2 methods for correction for aluminum wiring. Rewire the home with copper wire. While this is the most effective method, rewiring is expensive and impractical in most cases. Use copalum crimps. The crimp connector repair consists of attaching a piece of copper wire to the existing aluminum wire branch circuit with a specially designed metal sleeve and powered crimping tool. This special connector can be properly installed only to the matching AMP tool. An insulating sleeve is placed around the crimp connector to complete the repair. Although effective, they are expensive, typically around $50 per outlet, switch, or light fixture. Although not recommended by the CPSC as methods of permanent repair for defective aluminum wiring, the following methods may be considered. Application of antioxidant paste. This method can be used for wires that are multi-stranded or wires that are too large to be effectively crimped. Pigtailing. This method involves attaching a short piece of copper wire to the aluminum wire with a twist-on connector. The copper wire is connected to the switch, wall outlet, or other termination device. This method is effective only if the connections between the aluminum wires and the copper pigtails are extremely reliable. Pigtailing with some types of connectors, even though underwriters' laboratories might currently list them for the application, can lead to increasing the hazard. Also, beware that pigtailing will increase the number of connections, all of which must be maintained. Aluminum Wiring Repair, our Inc., of Aurora, Colorado, advises that pigtailing can be useful as a temporary repair or in isolated applications, such as the installation of a ceiling fan. Copper aluminum revised connections. According to the CPSC, these devices cannot be used for all parts of the wiring system, such as ceiling-mounted light fixtures or permanently wired appliances. As such, copper aluminum revised connections cannot constitute a complete repair. Also, according to AWR, these connections often loosen over time. Alumicon. Although AWR believes this method may be an effective temporary fix, they are wary that it has little history and they are larger than copper crimps that are often incorrectly applied. Replace certain failure-prone types of devices and connections with others that are more compatible with aluminum wire. Remove the ignitable materials from the vicinity of the connections. Aluminum wiring can be a fire hazard due to inherent qualities of the metal. Inspectors should be capable of identifying this type of wiring. Repair methods. Since the early 1970s, several methods have been tried to improve the contact between aluminum wire and the junctions and receptacles. The single biggest issue is that it's very difficult for a contractor to know where all of the hidden junction boxes are in an older home. Rewiring in copper. This is obviously the best choice by far as it completely replaces the aluminum branch circuit wiring. However, this is very costly and disruptive. Pigtailing copper. A method many electricians tried was to pigtail a piece of copper wire onto the aluminum wiring using a wire nut. There were even special purple wire nuts produced with antioxidant paste in them designed for this application. However, this repair did not work as intended as wire nuts are not able to overcome the expansion problems of aluminum. This is not considered an effective repair. Copper aluminum revised switches and receptacles. These were designed to replace previous copper aluminum receptacles as they had a higher quality conductor lug assembly. However, this addresses only the issues of switches and outlets, but not the connections in boxes. This is not considered an effective repair. Copulum connectors. These are the recommended upgrade for aluminum wiring. A special crimp connector and crimping tool are used to pigtail a piece of cotton wire into the aluminum conductor. It is then covered with a heat-shrunk insulation. This is the only CPSC-approved repair, but some connections still may be inaccessible. For more information about inspecting aluminum wiring during a home inspection, please read the inspection article located at www.nachi.org/inspecting-aluminum-wiring-during-home-inspection.